What NASA found inside the sun defies everything we thought we knew. Stellar origin, the cradle of our star king. It all began on a silent night of the universe, when a gigantic cloud of gas and dust, invisible to our eyes, floated alone in a remote corner of the Milky Way. That cloud, called a giant molecular cloud, contained the remnants of ancient stars that had lived and died long before the sun existed. For millions of years, the cloud drifted in calm until a shockwave, probably from a nearby stellar explosion, triggered the collapse of a dense region within it. That collapse was the first heartbeat of our solar system. Inside, a sphere grew denser and hotter, the core of what would soon become the Sunday. As gravity compressed the gas, the temperature rose until it reached about 10 million degrees. It was then, for the first time, that hydrogen nuclei began to fuse, releasing an enormous amount of energy. That nuclear fusion was the true birth of the Sunday. There was no fire, no noise, only a light that never went out. Around that forming star, a rotating disk of dust and gas gradually flattened due to motion and gravity. There, the planets, moons, and asteroids were born. Each particle in that disk decided its fate. Some would fall into the sun's interior, others would merge to form worlds. Our own planet was born from that process, in the warmth of a young star that had just awakened. Over time, the sun reached a perfect balance between the gravity pulling it inward and the pressure of energy pushing it outward. This balance is known as hydrostatic equilibrium, and it is the secret to the sun's stability. Since then, it has shone tirelessly for more than 4 billion years, feeding life on Earth and setting the rhythm of time and the seasons. But what happens inside the sun's core is even more incredible than we ever imagined. The solar core, a forge impossible to replicate. To understand what truly happens inside the sun, we must completely abandon Earth-based logic. In its core, where the energy that gives life to the solar system is produced, the conditions are so extreme that no human technology has ever been able to recreate them. At about 15 million degrees Celsius, and under a pressure more than 250 billion times greater than our atmosphere, the solar core is not a place, but a state, a perpetual nuclear furnace. In this hell of plasma, hydrogen atoms have been stripped of their electrons, becoming bare protons that, due to gravity, are forced to come closer than we can imagine. Although these particles naturally repel each other because of their positive charge, a small fraction manages to overcome this repulsion thanks to a phenomenon called quantum tunneling. This marvel of quantum physics allows protons to do something that seems impossible: pass through an energy barrier they could not overcome by classical means. When they succeed, they come into direct contact and fuse, releasing a colossal amount of energy in the form of radiation. The main cycle in the sun is called the proton-proton chain. In it, two protons combine to form deuterium, emitting positrons and neutrinos. Then, this deuterium fuses with another proton to produce helium-3, and finally, two helium-3 atoms merge to form helium-4, releasing more protons and photons. Every second, the sun transforms about 4 million tons of its mass into pure energy. That is the price of its light, an energy that escapes the core in the form of gamma rays, beginning a journey of hundreds of thousands of years before reaching the surface. This process is so slow and chaotic that a single photon can take longer to leave the sun than humanity has taken to develop all of its recorded history. However, there are particles that do not face that labyrinth. Neutrinos, generated in the same fusion processes, escape almost unhindered and offer us a direct window into the sun's heart. They were essential in confirming that the sun indeed obtains its energy from nuclear fusion and not from chemical processes, as was once believed. The impossible journey of a photon. Imagine a photon born in the sun's core, in the midst of that scorching nuclear dance. Its existence begins as a burst of energy released in a fusion reaction, but what awaits it is not a direct trip into space. On the contrary, a tortuous and colossal journey lies ahead, one that defies any notion of linear movement. This photon, like all its companions, must cross the sun's inner layers in a chaotic process known as radiative diffusion. In the core, the density is so extreme that each photon can only travel a few millimeters before being absorbed and re-emitted by another particle. This process repeats trillions of times. It is as if the photon were trapped in an ocean of plasma, where every attempt to move forward is frustrated by a collision. Its path is not a straight line, but a random sequence of tiny jumps, a random walk inside a boiling sea of atoms. This journey can take anywhere from 100,000 to 500,000 years. That is how opaque the heart of our star is. Upon leaving the core, the photon enters the radiative zone, which occupies roughly 70% of the sun's radius. Here, conditions are still hostile, though the density gradually begins to decrease. Energy is still transported by radiation, but the jumps become slightly longer. The trip remains exhausting, and the direction unpredictable. Each interaction slowly transforms the photon's energy, degrading it from gamma rays to X-rays, then to ultraviolet, and finally to visible light. At the upper boundary of the radiative zone, the photon encounters an enigmatic region, the tachocline. This thin layer marks the transition between the radiative region and the convective zone. Here, plasma motions begin to acquire a dynamic component. Radiation no longer dominates, convection does. At this point, the solar matter becomes transparent enough to allow the bulk movement of hot plasma. And then, the photon is trapped by a bubble of plasma that violently rises toward the surface. This is the convective zone, a boiling cauldron where heat is transported like in a pot. In gigantic eddies, thousands of kilometers in diameter, plasma rises, cools, and falls again, creating a pattern of movements that shapes the sun's granulation, the moment the sun touches us. After hundreds of thousands of years trapped in the chaos of the sun's interior, the photon reaches the final frontier, the photosphere. This layer, barely 500 kilometers thick, is the sun's visible surface. Here, for the first time, the photon has a real chance to escape into space. The density has dropped enough that most photons are no longer reabsorbed, but are released in a straight line toward the cosmos. It is in this layer that the light reaching our eyes is generated, where the sun becomes something tangible for life on Earth. But what is truly astonishing is that this particle of light, which began its journey hundreds of thousands of years ago in the depths of the core, will travel the 150 million kilometers separating the sun from Earth in just over 8 minutes. 8 minutes against 500,000 years. The shortest stretch in the end is also the fastest. When sunlight bathes a field, lights up a city, or awakens your senses in the morning, you are receiving a distant echo of an event that occurred when mammoths still walked the Earth. This journey of the photon is more than a physical path. It is a symbol of everything our star represents. It is not only the source of life, but a cosmic energy machine, a relic in constant evolution that transforms matter into light and light into time. Over 5 billion years, the sun has gone through activity cycles, magnetic storms, plasma eruptions, and yet it maintains the delicate balance that allows our world to exist. A balance that will one day end, but for now, continues to sustain us. And the light we see is not just light, it is history, it is science, it is poetry. It is the testimony that we live in a corner of the universe where a star chose not to be violent, but generous. Where a star chose to touch us with its warmth and gift us its photons. Thank you for joining us on this journey to the heart of the Sunday. If you are passionate about discovering the secrets of the cosmos and want to keep exploring the mysteries of the universe, subscribe to Midblown Space. Because here, every ray of light has a story to tell.